Hello and welcome to this lesson video on construction resources. I'm Dr. Hisham Said from Santa Clara University, and it's a pleasure to have you watch this video. In this video here, we'll learn about the impact of availability of skilled workers and labor in the construction industry, and also identify the different equipment that can be used for different major operations within a construction project. So if you think about a facility that's being built, it's made up of systems. So you have the civil system, the utilities, and then the structural system. There is the electrical, mechanical, plumbing. All of these systems make up that facility. And then every one of these systems is made up of a component. So a structural system is made of beams, columns, slabs, and each one of these is built with a possible way or a possible operation of many ways or many different possible operations to construct or install this component. And every one of these operations will have different variations or ways of using resources or inputs. So resources are an input into an operation, and then at the output of the operation, whatever component you will have in that system for this facility. A typical breakdown of resources or inputs for an operation is three things: material, labor, and equipment. In this video here, we'll focus on labor and equipment, kind of general overview of each. Material is dependent on the operation. So for structural slabs, then material are concrete. So you learn about these in other classes. So we'll focus here on the manpower and the equipment power that's used in construction. So skilled labor is and has been a major scarce resource that's actually putting the industry at an edge here. There's a lack of skilled labor, and it has been like that for many years. We'll not get into reasons and the dynamics of that, but it is a reality we live in. Skilled labor is organized into trades. So this is here not an exhaustive list of trades, but they're very respectful. Every trade has its own skills and knowledge sets that you have to learn through very rigorous apprenticeship and training under journeymen who are proud of their trade and skills. So you can see here carpenters. There are technicians for HVAC systems. Millwright are those who are install industrial equipment. Steam fitters are those who install piping that's under pressurized and transferring fluids or steam. Steam, but pipe fitters are more for pressurized fluid piping. So you see they're pretty specialized. And they're dependent on hardworking women and men. Each trade is proud of these people. Now these skilled labor, they have needs, and they are a little in conflict with the construction businesses or companies. So construction industry is cyclic in nature. So we're very aware of the economy cycle, and construction also is following that. So ups and downs. In the up, everyone is happy, and actually everyone complaining about the unavailability of workers. But in the downtime, workers want to have stability in the work. They don't want to be laid off, and also have a safe workplace. But then employers in the downtime, they want to have the flexibility of firing and hiring. And also having the safety measures and all of these precautions will cost money and will limit the flexibility of the business. So there have been historically and socially that conflict between workers and businesses, and that's also an attribute here in construction. which as any business, there is the idea of workers being unionized or not. In construction, it is one of the early fields that have been like witnessing unionization from early days. So the first union here was the carpenters, and then a lot of unions followed that. So the electrical union, electricians union, which is called International Brotherhood of Electrical Workers. You can see here, like there's a couple of here that has also brotherhoods. Yeah, the International Brotherhood of Teamsters. Teamsters, so those are working on heavy equipment operators. So it's more like a social network that supports worker rights, and brotherhood is just a reflection of that commitment from the worker to the union. Union membership have been declining since mid last century. Construction is a little better than other private industries, but still it's pretty low. If you think about it, it's between 12 to 16%. And there are many reasons, social and economic reasons for that. So we'll not go into this, but you know now that there are 14 to 16% of workers in the construction industry are represented by union, the rest are not. What we call those are not covered by union are called open shop. So those are working for contractors that are not committing to unions. They are called merit shop or open shop builders or contractors. So this is a comparison here between union contractors and open shop contractors. So union workers are represented by unions, union halls, and they are usually not a national organization only. There are local chapters, or we call union halls, within every jurisdiction. In open shop, it's pretty open. There is no representation here. Workers trust their employers will take care of them. And this is why kind of worker rights are mandated by contractors in open shop. But in the union, it's the union representing the workers to negotiate with the business to set a collective bargaining agreement here, which outlays in details the rights and responsibilities of the workers and the business, or what we call the employer. And this is why workers in the union are more loyal to their union halls. They work for the union, not for the companies. Kind of, this is the mentality here. But in open shop, workers are more loyal to the companies in return of that understanding that the employers will take care of them. But there is no guarantee, right? There is no union protecting the rights. In the union, the workforce is less mobile because every worker is signing or is enlisted in a local union hall. It's not easy to have a worker moving from South Bay, let's say in San Francisco, to East Bay, somewhere a little north, or even Southern California. It's not easy. That mobility of workers is not easy, but it's not the case in open shop. Generally, there is understanding that union workers respect and uplift safety standards, which is not the case for open shop. And in return, they also expect having higher pay rates and benefits. Benefits in unions are very good, and that's the main driver for workers to join unions, the benefits. And then the next thing is the bad thing in union is there is less cost efficiencies when a business operates within this category, being a union contractor, because union enforces contractors to use specific size of crews and composition of crews. So a crew should be mostly made of journeymen, these experienced trade people, and then fewer people who are called apprentices. So it's mostly highly paid people. But open shop, you don't have that limitation, so you can have one or two highly paid trade people, and then more of unskilled people, so that the pay rate here, what we call here the composite pay rate of the crew, open shop is more competitive. They pay less compared to the union. So they can compete better in projects compared to union contractors. In general, there's less higher flexibility because you have limitation here. It's only 15% of the industry are union. Sorry. And also another thing is you cannot hire a worker just by going there and come and work with me. You have to go to the union, and the union have a referral system, like a list, a wait list. You have to go through the wait list and pick the one worker who you want to work with them, or you want them to work with you. In open shop, there is more flexibility. So you can summarize saying that open shop is more flexible, have more cost efficiencies, but union contractors kind of have more higher standards of safety and also kind of quality, because the union workers go through more rigorous training program and apprenticeship programs. This is just an example here of this relationship between a GC employer, so which is represented in the US by AGC, and then the GC have subcontractors. One of them is electrical contractors, which is represented by NECA, National Electrical Contractors Association. NECA has signature collective bargaining agreement with IBEW, International Brotherhood of Electrical Workers. So AGC commits to work with union workers through their union subcontractors. Not open shop or merit shop contractors, it's represented by ABC, mostly in the US. And you can see ABC manage their own training programs, not of course similar to the union apprenticeship program, but and the ABC is kind of the representation of GCs or general contractors, and they subs to open shop merit shop contractors. In this case, for electrical, it's IEC, Independent Electrical Contractors. And you can see here there is no link further. There is no unions. So IEC have their training programs that open shop workers can go through. But again, it's not that rigorous generally compared to union apprenticeship programs. So unions is very, is not an easy topic to discuss. There are a lot of politics and territorial aspects to it. If you want to learn more about that, go to New York. It's a very tough ground for unions and very hostile actually to open shop in some way. But unions here have their tactics to push for their cause, and they have a good social cause, which is social worker welfare. But they use some PR, public relation, and media ideas to attract workers to join them. And one of the things here famous for unions is using the rat inflatable here, and beside construction sites that the builders are being built by non-union workers and non-union contractors, and they use strikes here, so convincing the workers on this job site to strike in return to push the builder to sign for the union. The rat here is just a representation of that bad face of capitalism and those businesses that steal the wages of hardworking trade-skilled workers. So it's a very interesting topic, but we'll not get into details of labor unions here. So we discussed the first resource, which is labor. The next main resource here is equipment. So choosing the right equipment will make or break your operation, your productivity, and your cost. So an example here, if you're excavating or digging, should you use a clamshell? So we'll discuss that briefly in the next slide. So we'll use a clamshell, or we'll use a backhoe, or use a version of backhoe smaller called bobcat. Many factors can affect that, so we'll not get into detail of that. But for example here, clamshell is more used into deep excavation, where you don't have a lot of maneuvering in the pit inside the excavation hole. Backhoe is most commonly used in surface excavation or easy, typical excavation jobs. And bobcat is used for trenching or hard to reach excavation jobs. Productivity, of course, backhoe is better. Clamshell, not that good, but it can reach to lower elevations. Bobcat, not that good, but it's agile and can reach to tough spots. So we'll cover here some example equipments for some of the main construction operations that you would see on any typical site. The first thing here is excavation. So excavation is done by different equipments. Some of them are very common, some of them are not that much. So front shovel is used in excavation for big, huge excavation jobs. So earthwork, dams, or it's mostly used in mining. So you'll see a lot of mining equipment are shared with construction. So trucks and excavators and dozers and all of that. So a lot of concepts in construction also are shared with the mining industry. So front shovel, huge equipment, but not common in construction that much unless it's a big, big project. And they dig mostly above the level of the equipment, above the level of the ground. Backhoes are more common and they dig more, can reach lower level under the ground. So front shovel scooping above the ground, backhoe is digging below the ground level where they are. Backhoes also are agile. They can change the functions based on the attachments. So instead of the bucket, you can have a impact hammer and you start using it for taking out all the structures. So it's very, very agile equipment here. So this equipment here is actually a crane. So it's not an excavator, but it's used in excavation by having these attachments, the clamshell and dragline. It's not common in most construction projects. It's common more into deep excavations or in marine construction. So if you have a canal and you want to clear it or make it deeper, then you would use a dragline or a clamshell. The soil should be a little loose, so you can actually dig using clamshell or a dragline. Loaders are not used directly to excavate unless it's similar to the front shovel, but they're mostly used with the backhoes. So the backhoes will dig and pile the soil, and then the loader will load from the pile and load the trucks for hauling it. So these are the equipments used in excavation. Mostly construction projects are dependent on backhoes and loaders. Bigger projects, you'll see clamshell and drag lines. Front shovels are more into the mining industry, not that much into construction. Now, once you dig the soil, you need to haul it away. So there are different equipments used to haul the soil or move it. The first one here, and you can see here this chart is showing their uses, where they would be appropriate to use over different distances of hauling here. So dozers are heavy equipments. They are used to push the soil. They don't load the soil. They don't get loaded with the soil. They skim the soil and push it. And because of that pushing, they can only move the soil from a point to a point that are nearby up to 200, 300 feet. These are heavy equipment. They won't move on tracks like tanks, like war tanks. But you can replace the tracks with wheels, not replace it, but you have a different version of the equipment on wheels, and that will a little increase the distance that this dozer can push the soil. It's more mobile than moving on tracks. After dozers, there's the loaders. So loader is kind of a dozer, but it's less. It's not that heavy, and actually the bucket you can lift it, but the dozer you can just change the angle of the blade. So the dozers use blades, but loaders use buckets. You can actually load the bucket, move it, drive with the bucket full, but you cannot also drive for longer distances. So the next would be scrapers. So scrapers are very interesting equipment. So they have this billy here, where they go into what we call the cut area, where you actually cutting the soil or digging the soil, and they move it to the fill area. So these operations, they call it cut to fill. So you go to the cut area, and the scraper have the belly. They lower the belly and scoop the soil. It's exactly like scooping ice cream, kind of. So they scoop the soil. The soil, when it's scooped, it gets into the belly, and then once it's full, the belly lifts up. So now you're moving as if you are a truck. The scraper moves, and then once it reaches the fill area, then the belly opens, not lowering, but opens the gates, and then there is something pushing the soil out. So you start spreading the soil. So you scoop the soil in the cut, and in the fill you spread the soil. You push it out of your belly, and it spreads while your equipment is moving. So just whatever, each one of these equipments, I don't have actually to explain a lot. Just go to YouTube, any video sharing platform, and just search for the equipment. You will find tons of videos showing you, and you will get more understanding. But the point here I'm trying to deliver is that each equipment is appropriate for a specific distance of hauling. So we have covered the dozers, loaders, scrapers, and then the ultimate hauling machine here are trucks for sure. Trucks can be different shapes. So this is what we call the articulated trucks. So you'll find in this point here, there's kind of a big, huge hinge. So the bucket or the box of the truck at the end can rotate in a different angle than the cabin of the driver. That makes the equipment more versatile and can drive on rough ground surfaces. Compare that to the regular trucks, hauling trucks we see on the roads. These are fixed frames, rigid frames. So they don't, like if you drive them on rough grounds, they either flip or it will not be stable. It will not be a safe drive for them. So articulated trucks are more into on-site. They are not on the road kind of hauling operation. But if you're going to haul on asphalt or typical roads we use, then you will use on the road haul trucks or dump trucks. So this is kind of a big mapping picture of what hauling equipments are used. Better are trucks for longer distances, then scrapers, then loaders, and then finally dozers. The next operation here to cover is lifting, which cranes. So cranes can be mobile or can be stationary, what we call tower cranes. Mobile cranes even have different variety or spectrum of mobility here. So there is the heavy cranes, which are the crawler cranes. So you see these in major projects where you have big equipments that you need to lift or big steel sections. So they come on the crawling, meaning that they move on tracks. They're heavy to move. They're not that mobile. There is on the other extreme here, very other extreme, there is the cranes for heavy lifts. These cranes, you build them like as if you're building a building. You put them together. Crawler is kind of that, but these cranes here are more for heavy, like you're lifting a whole span of a bridge. So it's very special cranes that are used in bridge construction or marine construction or industrial oil and gas construction. So very rare to see. If you see one, you will be lucky. It's very fun to watch. Crawler cranes are more common, but in more bigger projects. These other cranes are more mobile, are more common in projects. So let's start with the more mobile within the site, rough terrain cranes. So these are kind of cranes that can easily maneuver within the site, but need flatbed trailers to move them from a site to a site. So they're mobile within the site, but not between the sites. These are rough terrain. The other cranes are on trucks. So all terrain is a truck mounted crane, but it's a little lighter than these two telescoping or lattice boom truck mounted cranes. They have less capacity, but they're more mobile. They can reach to typical sites. Truck mounted here are a little bigger. You can see here the number of axles, more than the all terrain. In general, when you have the boom of the crane is lattice boom, meaning that it's kind of looks like truss. It has more capacity. It's more efficient load-wise because the structure of the boom here is more efficient. It's less weight of the boom compared to the weight you're lifting. Telescoping is not that efficient compared to the lattice boom cranes, but it's more, you know, expanding. It gives more flexibility. It's easier to set up this telescoping boom truck mounted compared to lattice boom truck mounted. So the common ones you'll see are all-terrain or telescoping boom mounted train, and some industrial projects where you want to have little lifts here and there, rough terrain, and industrial projects that are mid-size or commercial projects where you have air handling units and steel sections, crawler cranes. Lattice boom is kind of old-fashioned of telescoping, but still you'll find some of them. And heavy lifts are just very rare and very like huge oil and gas and transportation bridge projects. These were the mobile cranes. Now the tower cranes are, you've seen them, if you live in a city, you've seen them in downtown and high rises, or sometimes even like projects that are not high rises but have a lot of lifts to make. Tower cranes are stationary. You have to build them on the site. They actually, if they're the typical ones, they have their own foundation. So you have to build the foundation of the tower crane, build the tower crane itself, and then the tower crane is actually self-climbing. It can climb on itself. You don't have to do anything after that. But the first little height, you have to construct it yourself with a crane. So you use a crane to build this tower crane. And then this tower crane has a maximum standing height, which doesn't require bracing. But once you exceed that freestanding height, you have to brace it to the building. So these heavy section steels are bracing the tower crane and connecting it to the shear walls or the shaft within the building. So it's pretty tremendous effort to have a tower crane on site. So it's a big cost portion of the project to have a tower crane. And the decision to make a tower crane is not easy. You just don't say, I will use a tower crane. You have to be very sure that it's more economical to use tower crane than bringing a mobile crane on site. There are many other technical differences, but tower cranes are more used in sites downtown where you don't have the flexibility and space to have a big truck coming and lifting. And it's also helpful to reach higher elevations that the mobile cranes with their boom angled cannot reach. But it's not an easy decision just to say, I will use a tower crane. There are a lot of considerations need to be done. The last system, so the next operation that we'll see here is dewatering. So in deep excavation, when you go digging in the ground below the water level, the groundwater level, to be able to actually do that dig and excavation, you have to suck the groundwater, at least temporarily, until you reach the level, build the structure down there, and then backfill, and then you allow the water to go back to the groundwater level that was naturally there. So how you suck the water is using dewatering systems. So you see here, dewatering systems has wells. So you bring a special equipment, drill the well, have a pipe in there with different, filtration systems. And then you connect these wells to collection pipes, and then you have a pump that sucks the water 24 hours, 24/7. Until you finish your business with the excavation, and then you remove everything. You can see in this picture here, these are the little pipes here. These are the wells, and these are the collectors, right? Here you go. And then they are all going up to the main pump here. So dewatering is required whenever you're digging below a groundwater level. It's always a question when you have an excavation, what's my water level, groundwater level? And if you're gonna need a dewatering system or not. The next here is piling. So piling, you're building piles that will support the structure, and you cannot depend on shallow foundation. You have to bring your foundation all the way to a reliable bedrock here. So you will transfer the load of the foundation to there. Piles can be augured piles or driven piles. Auger piles comes from the auger head, so you're drilling into the ground, and they'll lift it up with the soil, shake it, and you keep doing that until you reach the level of the pile depth you want to go down. While you do that, you secure your opening with this steel pipe until, the top layer of the pile, because this is typically not a strong soil, so you have to support it with a steel pipe, a big one. And while you're digging with the auger, you fill the hole with slurry, kind of watery mud that sustains the pressure, and it doesn't allow the hole of this pile to cave in. And you keep digging until you reach here the end. And then what happens is, let's skip that, these are technical details, you're kind of trying to improve the strength of the pile by making it a little spread at the bottom, so it's having more bearing capacity. But here, all of this green is just this slurry liquid, what we call bentonite, and you drop in the rebar in this pile, and you drop a pipe, which we call the shut. It's a pipe to deliver the concrete to the lowest point of the pile, and you keep dumping the concrete and lifting the pipe up the shut slowly until you fill this hole with concrete, which you filled before with the rebar reinforcement, and then you have a finished pile. So it's a very tedious process, but it was one of the it's very efficient if you have many piles in place. It requires a lot of equipment, a lot of setup, but it's a good for typical piles, because the depths you can reach with this method are bigger, longer, and deeper than driven piles. So driven piles are piles that are using mechanical power to drive a pile into the ground. So the pile can be steel, concrete, or wood, and you can use here hammers, literally, like, it's not our hammer, but you use here the mechanical power to lift a weight and then just leave it to hammer the pile in, and you keep doing that. Or you use vibration hammer, impact hammer, or another way is you drive the pile by vibration. So by shaking something into the ground, it will, by its weight, it will be driven. So the field of driving power piles, or driven piles here, is very technical, and geotechnical engineers will study that more in details. But from construction perspective, it's good to know generally what equipments are being used. So we're just introducing here what different equipments are being used. Generally, you have augured, drilled piles, and there is a driven piles. So I recommend that in your free time, while you're surfing on the internet, just Google for all these equipments, watch videos, and this is actually the way to learn about these different equipments. So that's the end of the video. We'll learn here about the two of the main resources that are needed for a construction project. Labor, we learn about union versus merit job, and also we kind of have very introductory big picture of the type of equipments used in different operations, excavation, hauling, lifting, dewatering, piling. So hopefully it's informative, big picture. If you want to learn more, the web is a great resource, videos, a lot of videos to watch and learn. All right, thank you so much. Looking forward to have you in the next video. Thank you.